Welcome. This is Algebra 2, Semester 2, Unit 9, Section 9.7. We're right at the end of this unit. This is our last section with it. Today, what we want to do is we want to solve quadratic systems, linear quadratic systems by graphing. So that's why I wanted you to kind of know how to graph those different conic shapes, because sometimes they'll show up on these. And instead of just a parabola, it's kind of conic shapes and linear lines that we're graphing all on one. So the first thing here that I ask you to do is to graph. I switched this. I don't know if I'll get it switched on your notes. So if you have x squared minus 7x plus 3 equals 0, I wanted to switch that to the ellipse 25x squared plus 4y squared equals 100. Now that looks similar to one that we've graphed, but there's a slight twist to it. So I already made the mistake of telling you it was an ellipse. You would know it was not a circle because you can see that your x and y coefficients are not the same. In a circle, your axes will be exactly the same distance with the radius involved. There might be some shifting, but they'll be the same distance from that radial point. So here we go. The first thing, we set it equal to 1. $25 goes into 100 4 times. So we have x squared over 4. 4 goes into 100 25 times. So now we have y squared over 25. And 100 over 100 is 1. So this time we can see on our y-axis, this is a vertical ellipse because our y-axis is 5 and 5. So we come up positive 5. And we come down negative 5. For the x, we go out negative 2 and positive 2. Okay, and we get our ellipse. Now we want to put the system on there. So now we take this linear equation. We get the y by itself, divide by a negative, so we get 2 over 1 is our slope and negative 3 is our y-intercept, so we come down to negative 3. We rise 2 and we run 1 to the right because it's positive slope. And that shows us a system with an ellipse and a linear line. I would ask that you highlight the solutions. It is the point that makes both equations true. So there's a solution. And there's a solution. Now in class, if we have enough graphing calculators, then I will show you how to find those solutions on the graphing calculator and have a specific point. But if you're not given a calculator, or if I don't have enough, then just mark the graph with solution, solution, and then we know roughly what value they are. Okay? The next problem, here we can see that is a circle because there isn't any lopsided numbers with the x and the y's. So we know that 16 is equal to the radius squared. Go back to the previous lesson if you've forgotten what the formula is for a circle. So that means that our radius is 4. We don't have a plus or minus with the x or the y, so we know that our center of our circle is at 0, 0. So we go to 0 and we come out 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. So now we just roughly, and again in class, I do have compasses that you can use on these graphs. But here at home and just getting the idea, just go right ahead like I do and just kind of sketch it for what you've got. Okay, now we have a linear line. We know it's linear because it's x to the first. We have a linear line and it's all ready to be graphed. We go to -1, put the point for the y-intercept. We go to the slope, which is 1 over 1. We rise 1, run 1. Rise 1, run 1, rise 1, run 1. And we just graph that right across there. Okay, again, mark the solutions. There's a solution. And there's a solution. Now, my question for you, do we always end up with two solutions when we're graphing quadratics and linear functions? Do we always get two solutions? Well, according to the bottom of the next page, this is your last page, page 11, we can have the two solutions, like we just saw, but we could also have one solution, and we could have no solutions. Right now, go ahead and draw what you think those would look like. Pause the video and draw them. There's my examples of one solution and no solutions. Okay, the last thing we're going to do, I'm going to show you how we would solve these systems, not by graphing, but by substitution. Y equals -3x plus 10. So you plug it in for the y. We get x squared plus -3x plus 10 squared equals 10. Okay. Now we go ahead and we square that. So -3x plus 10 times -3x plus 10. -3x times -3x is positive 9x squared. -3x times 10 is -30x. -3x times 10 is -30x. So -30x and -30x would be -60x. And then your last term, 10 times 10, is 100 equals 10. Don't forget to bring down this x squared. Now we combine our like terms. That's 10x squared minus 60x plus, it would be plus 100, but I want to get rid of this 10 over here so that I can set it all equal to 0 and factor, figure out what my x is equal to. So that would be 90. First thing that I would factor out would be 10. So I get x squared minus minus 6x plus 9. Okay. Now I want to find the factors that multiply to be 9 and add to be -6. And I realize it would be 3 and 3. So we've got a perfect trinomial square. X minus 3 squared. Because 3 times 3 is 9, and -3x and -3x would be -6x. So if we solve that, x would equal 3. Okay, now because we're solving for a point, we have to plug in and find the y value when x is 3. So I just plug it into this equation here. Y equals negative 3 times 3 plus 10. Negative 3 times 3 is negative 9 plus 10. Y equals 1. So that tells me my point is 3, 1, and I could look at this and say, well, that is a circle. This is a line with a negative slope, so I'm guessing it's going something like that, with 1 point. You don't always have to sketch it. I just thought that you'd like to see that you can actually visualize it after what we've done in the last lesson. So our last one to do here, take this value for y and plug it in. We get negative x minus 1 squared minus 2x minus 10 equals 0. So we squared this negative x minus 1. Negative x times a negative x is a positive x squared. Negative 1 times negative x is positive 1x. Negative 1 times negative x is positive 1x. So positive 1x and positive 1x is positive 2x. Negative 1 times negative 1 is a positive 1. Minus 2x minus 10 equals 0. Positive 2x and a negative 2x, those will cancel each other out, and we get x squared plus 1 minus 10, that would be a minus 9 equals 0. To get the x squared alone, we add 9 to each side. X squared equals 9. Take the square root. X equals plus or minus 3. That means that you have got two different x values. You've got a plus 3 and you've got a minus 3. So now we have to plug this plus 3 in. I plug it in to this very first equation here. So a positive 3 plugged in would be negative 3 minus 1 would be negative 4. I plug a negative 3 in. A negative negative 3 is positive 3 minus 1 is 2. So in that case, we've got two solutions. That is the end of Unit 9 for this class. You should have a pretty good idea of how to solve systems now. Have a great day. We'll see you in class tomorrow.